Hello students, welcome back. How are you? I hope you're all healthy, wealthy, fine and very good. Now students, we were studying Euclid's geometry and in that we had gone through very theory part of that, and we have covered the axioms, the postulate, and we were doing questions based on it. In that chain we have had discussion why is axiom 5. Now what is axiom 5? You should know that, and you should not confuse this with your postulate 5. So axiom 5 was whole is greater than part. Whole is greater than part. This was the axiom 5. Okay. Now, what is of your concern is, in a list of Euclid's axiom, consider a universal truth. It is considered to be a universal truth. Why? You need to explain that. Okay. So, what is saying that whole is greater than part? If I am telling you that you are going to have a pizza like that, okay, and then I am saying that I am going to take a part of it. Whether the part will be bigger or the whole pizza will be the bigger. Obviously, the whole pizza will be the bigger. That is the universal truth. That is universally accepted all across the world. Okay, that whole will always be bigger, will always be greater than a part of it. Okay, so this is Euclid's axiom 5 states that the whole is greater than the part. Since this is true for anything in any part of word, so it is universal truth. It is so obvious thing. Okay, so here it is a diagrammatic representative of this, because he having ordered a pizza. Okay, and this pizza came into these slices, and if I am demanding you for one slice here, okay, so this one slice is mine, I am saying, right? If I am saying that one slice is mine, then this slice, the part of it, the part of the pizza will always be smaller than the pizza, or you can say that the whole pizza will be greater or bigger than the piece of it or part of it, right? Okay, so is it understandable to you guys? Now, moving to our next topic, that is equivalent versions of Euclid's fifth postulate. I've told you when we were discussing the postulates of Euclid, I've told you that the fifth one is very going to be very important postulates. Okay, and you are having some questions based on it. Let's have this. No intersection of line will take place when the sum of the measures of the interior angles on the same side of the falling line is exactly 180 degree. Okay, now there are many versions of Euclid's fifth postulate. You can say that the many versions are based on Euclid's fifth postulate, right? Okay, now one of it that on the same side of the falling line is exactly 180 degree. No intersection of lines will take place then. If the sum of the internal angles are 180 degree, at this particular point, they are going to be parallel. They are not going to intersect. Okay, here. There are several equivalent points. There are several equivalent versions of this postulate. One of them is Playfair's axiom. Now, what is Playfair's axiom? This is for every line L and for every point P not lying on L, there exists a unique line M passing through P and parallel to L. What is saying? It's saying that we are having for every line L. Now, where is the line L? Here, this line is line L. This is the line L. Okay. Now, for every line L, for every point P, which is not lying. Now, point P can be everywhere, but not on the line L. Okay. Lying on L, there exists a unique line. A unique line is there exists. What is this? M. So, on that point, we can construct a line which is named as M, obviously here, passing through this point P that was not lying on the line L and parallel to L. So, that can be parallel to L, because if the point is not on the line, we can draw a line on the point which is going to be parallel to this given line. Is it clear to you now? Okay, so that can always be drawn, right? Now, this result can be also stated in the following form, that two distinct intersecting line cannot be parallel to the same line. Two distinct parallel lines, okay, cannot be parallel to same line. If some one parallel line is here and second line is here, so these are two lines, two parallel lines. These are two parallel lines, okay, and they are different in directions. So in that case, what happens that there cannot be another line. There cannot be another line which is parallel to both these two and these two, right? So two distinct intersecting lines, okay. If we are having two intersecting lines, that cannot be parallel to the same line. If this line is going to be parallel to that one, then this line, let's suppose it is L, this is M and this is N. If M and N are intersecting line and L is parallel to M, then L can never be parallel to N, okay. Now, the next example, consider the following statement. What is the statement here? There exists a pair of straight lines that are everywhere equidistant. Pair of straight lines are equidistant at every point from one another. Is this a statement as a direct consequences of Euclid's fifth postulate? First, you do think so, and if you think so, is that it? Then you need to explain it. Okay. So here we are taking a line L and a point P not on L. Okay, that we have done before. We are going to have a line L and a point P but not on line L. Okay, now by Playfair's axiom, which is equivalent to the fifth postulate, we know that the unique line M that we had studied just 2 minutes before, that here is a line M, okay, a line M, and which is parallel to L, right? Now, the distance of a point from a line is the length of the perpendicular from the point to the line, right? So here we'll be drawing a perpendicular to it and the distance will be there. Here the distance will be this, here the distance will be the perpendicular, okay. This distance will be the same any point on M from L and any point on L from M. Okay, so if you are measuring these distances, or if you are measuring these distances, these are going to be all same or all equal. Why so? Because yes, it is the another part, what you say it consequences of Euclid's fifth postulate, right? That this is going to be equidistant each and every point. So these two lines are everywhere equidistant from one another, okay, and yes, it is the consequences of the fifth postulate. Now, how could you rewrite Euclid's fifth postulate that it would be easier to understand? Okay, so Euclid's fifth postulate, so several easy equivalent versions of Euclid's fifth postulates are there. Okay, you can have it here. Two lines are said to be parallel if they are equidistant. What we had just proved in the example, we can write it that way, from one another, and they do not have any point of intersection. They are not having any point of intersection, first thing, and the second thing is they are having equal distance between them, these two lines. The perpendicular distance is same. So then by Playfair's axiom, there is a unique line M through P which is parallel to L. So this is the way you can write it. Okay, now the next one, the last one here. Does Euclid's fifth postulate imply the existence of parallel lines? Explain. Euclid's fifth postulate is totally about the parallel lines. You know the parallel lines, so now it is very easy for you guys to say that yes ma'am, it's simply a yes. Now what is next? Explain. Okay, we are explaining, don't be afraid. Euclid's fifth postulate is imply that for parallelism of line, because if a straight line L falls on the two straight line M and N such that sum of interior angles on one side of L. So first of all, what we are saying that line of a straight line L falls on two straight lines M and N such that the sum of the interior angles, this is the M and this is the N, okay, and this line is passing through them, right? Okay, so on one side of the two right angles in the Euclid's fifth postulate, the line will not meet on this side of it. That means these interior angles are having sum equals to what? The sum is equals to two right angles, right? So if they are having sum equals to two right angles or more than it, then on this side it's never going to meet. Okay, so this is the way, right? So this is the complete, this was the complete thing about the Euclid's geometry. I hope you guys understand it all well. There are some new things there, because all the things that we studied here, approximately all the things we have known, but not in the perspective of in the view of Euclid's. Now why it is different? Because the Euclid's gave that assumption. What we are studying right now is the modern geometry, that is Euclid's geometry. So try to understand that. Just try to not to relate all the things that you have already known in that. You are going to keep in mind for this particular chapter's question, you are going to keep in mind the Euclid's axiom, the Euclid's postulate, and then going to solve the question accordingly. And you have to know the serial numbers on first, second, third, fourth, fifth postulate. Same goes for the axiom, so that you cannot be distracted or you cannot be confused when it comes like according to axiom 5, according to postulate 5. So be aware of that. Okay, students, so just revise it completely, and we will be meeting in the next lecture, and we'll be revising all of it like in the summary part. Okay, so I'll meet you there. Okay, go back, study hard, and live your life. Bye bye.